Okay, this section of the spec is all about how to choose a statistical test, and this is all about analysing your results after you've done an experiment. How do you find out if what you've found is statistically significant or not? So that's the big question here. You've got to know what test to use so that you can find that out. So statistical tests are about finding out, could your results have happened by chance, or are they significant? Because we want to know that it's not just like this is what happened by chance anyway. We want to know that it's statistically significant. It's more than could have happened by chance. So if you remember, at the start of an experiment, we'd have our null hypothesis and our alternative hypothesis. Just as a recap, in case you've forgotten, null hypothesis says that the IV will have no effect on the DV. The alternative hypothesis is where it says it will have an effect. So that includes both directional and non-directional hypotheses. So you would have one of those, either directional or non-directional, and you'd also have the null hypothesis at the start. And then your results tell you whether to accept your null hypothesis or whether to accept your alternative hypothesis. So if your results show that your outcome could have happened by chance, then you would accept your null hypothesis. If your findings suggest that that it's statistically significant, then you would accept your alternative hypothesis. Okay, so how we choose it, there's 3 basic questions we have to ask. Firstly, is this piece of research looking for a difference or a correlation? What I mean by that is like a difference between 2 things, like between 2 conditions in an experiment. Difference in recall between condition A and condition B, or a correlation like correlation between shoe size and intelligence. So because that's kind of looking for similarity. So we want to know, is it looking for a difference or a correlation? What experimental design is being used? So is it repeated measures, is it independent groups, or is it matched pairs? And what level of measurement is being used? So what kind of data is it? And we're going to talk about all of these in a bit more detail. So difference or correlation. The hypothesis should make it really clear what it's looking for. So if it says there will be a difference between blah blah blah, it's looking for a difference. If it's looking for a correlation, it should state it's looking for a correlation. So that can include both a correlational analysis, and it might include investigations that are looking for an association between 2 things. So question 2 was, what's the experimental design? And the key thing here is that you've got repeated measures and matched pairs. They're what we call related designs. That's because the two groups of participants are related to each other. In repeated measures, it's the same group. In matched pairs, they've been matched in terms of characteristics. So independent groups would be an unrelated design because they're completely independent and separate of each other. Okay, levels of measurement. We've got 3 types of data that we will look at: nominal, ordinal, and interval. We'll talk about what all of those mean. So the first thing, nominal data, this is data that goes in categories, like male or female, or which newspaper does this come from? Is it the Times, the Sun, or the Daily Mirror? Discrete data, so each item can only appear in one of the categories. So if someone is male or female, they're only going to go into one category, or if they get 1 vote for their favourite football team, that only goes in one category. So it's discrete data in categories. Ordinal data is when the data is ordered in some way, so like a rating out of 10 of how much you like fish and chips or something. It doesn't have equal intervals between each unit, so if someone said that they gave fish and chips 8 out of 10, but someone else gave it 4 out of 10, that doesn't mean that the first person likes fish and chips twice as much as the second person, because it's not as precise as that. So it lacks precision. It's based on subjective opinions. 2 people might both say 8, but actually think different things. It doesn't measure something that's precise and measurable like in the real world, like a height or a temperature. It's like looking at a psychological construct, for example. So for that reason we call it unsafe data. We don't use it in its raw form to calculate from, but we convert it to ranks. So like the lowest rating, if someone gave fish and chips 1 out of 10, they would get the first rank, rank 1. And then you use the ranks to actually do your calculations. Okay, third type of data, interval data. So this is data based on numerical scales that include units of equal, precisely defined size. So for example, time, that's equal, precisely defined units. Temperature, weight. It's the most precise and sophisticated form of data. And this is our really important slide. You're going to have to learn this table, lucky you. So how to choose using your 3 criteria. So we've looked at those 3 criteria. If you remember, they were, is it a difference or a correlation? Is it, what's the design, and what type of data is it, what level of measurement? So this table tells you how you know what test to use. So if you've got an experiment where you've got a related design like matched pairs, and you've got an ordinal data, so people have ranked something, then you know you have to use the Wilcoxon test. And to help you learn this, someone's come up with this quite helpful phrase: carrots should come mashed with swede under roast potatoes. And this relates to the order that they come. So carrots should come mashed with swede under roast potatoes. Okay, so that should help a little, but you'll still have to learn it. This bottom line shows which ones are the parametric tests. The parametric tests are basically the best ones that you want to try and use if you can. So they can detect significance in some data sets that the other tests can't. So they're a lot better in that sense. There's 3 parametric tests only. That's those 3: unrelated t-test, related t-test, Pearson's R. And in order to be able to use one of those tests, it has to meet these 3 criteria. It has to use interval level data rather than rather than nominal or ordinal. The data has to come from a population that would show a normal distribution for the factor being studied. So for example, IQ, that would have to be the factor being studied, because you know that the population shows a normal distribution for IQ. So if you've got a random sample, then you would expect to see a normal distribution, so that would fit. And there should be something as well called homogeneity of variance, and this basically means that the scores in each condition should have similar dispersion. So for example, you could test each condition with standard deviation, and if you get similar scores for your standard deviation, then you're fine to use these tests. If not, then you need to use another one. Okay, so that is statistical testing, and you need to learn that table basically.